The most advanced record-keeping technology on Earth right now, cloud storage, is trying to solve a problem that a civilization without electricity, paper, or even the wheel already solved. How do you make sure a record is still true 100 years from now? Every civilization that grows past a small village runs into the same wall. People stop knowing each other personally. A farmer doesn't know the tax collector. A customer doesn't know the engineer who built the app they're using. And once strangers have to rely on each other, memory isn't enough anymore. Someone has to remember who owns what land, who paid their taxes, who owes money, what was promised, and to whom. And that memory has to survive even after the people involved are gone, because civilizations outlive individuals. This sounds simple. It isn't. Records get lost. They get faked. The people writing them down can be bribed, careless, or just wrong. Physical materials rot. Digital systems crash. And the moment people stop trusting the record, everything built on top of it starts to fail. Taxes go uncollected, debts go unpaid, ownership becomes a guess. So the real challenge was never just writing information down. It was building a system that strangers, separated by distance and time, could trust without ever meeting each other. 4,000 years ago, one civilization solved this with reed pins and knotted rope. Today, a technology company solves it with fiber optic cables spanning oceans. The tools are almost nothing alike. The problem they're solving is exactly the same. In ancient Egypt, the answer to this problem wasn't a better material. It was a person, trained for years to be trustworthy on paper before he was trusted with anything else. He was called a scribe, and becoming one meant years of discipline. Scribes learned accounting, geometry, legal language, and the exact administrative format the state expected. This training mattered because it meant a record from one scribe looked and worked the same as a record from another, even if they lived hundreds of miles apart and never met. Consistency was the whole point. If every scribe recorded a grain harvest the same way, using the same units and the same structure, then a record could be trusted even without knowing who wrote it. Scribes tracked almost everything the state depended on: land surveys, tax assessments, labor for building projects, and grain, which mattered more than almost anything else, because grain was food, currency, and tax revenue all at once. There was a problem specific to Egypt that made this even harder. Every year, the Nile flooded. That flood was essential. It renewed the soil and made farming possible. But it also wiped out the physical markers separating one person's land from another's. So every year, surveyors went back out with measuring rods and knotted ropes to reestablish exactly where each boundary had been, using the written land registers as the reference point. Without that written record, ownership itself would have to be renegotiated from scratch, year after year. These records weren't just filed away and forgotten. They were kept in temples, granaries, and administrative offices spread across the region, effectively early data centers. And officials didn't just trust what was written. They checked it. They compared recorded grain totals against what was actually sitting in storage. They compared land registers against what was actually being farmed. This created something close to an audit system thousands of years before the word existed. So Egypt's solution had three parts working together: standardized training, so records were consistent no matter who wrote them; multiple storage locations, so no single fire or flood could erase everything; and routine verification, checking the paper against physical reality. None of this depended on trusting one person completely. It depended on a system where individual mistakes or dishonesty could be caught, because the record could always be checked against something else. Microsoft is not tracking one region's grain harvest. It's holding the operational memory of more than 1 billion customers and 20 million organizations. Financial transactions, medical records, contracts, business data, all of it has to survive not just for a season, but indefinitely, and it has to be available instantly, from almost anywhere on Earth. The scale is different from Egypt by orders of magnitude, but the underlying logic hasn't changed nearly as much as you'd expect. Instead of training scribes, Microsoft standardizes data itself, fixed formats and protocols that let information be written, read, and understood consistently, no matter which system or which engineer is handling it. That's the modern version of a shared scribal training. It's not a person being standardized anymore. It's the format. Instead of temples and granaries scattered along a river, Microsoft operates more than 500 data centers, spread across more than 80 regions in 34 countries, all connected by over 800,000 kilometers of fiber network. The reasoning is identical to Egypt's. No single location should be able to take the whole system down. If a flood destroyed one granary, Egypt still had others. If a fire, a power failure, or a natural disaster takes out one data center, Microsoft's system is built to keep running from somewhere else. This redundancy is deliberately engineered. Azure's infrastructure is organized into what are called availability zones, groups of physically separate data centers positioned far enough apart that one disaster can't reasonably affect more than one of them. Data moving between these zones is encrypted by default, and the system is designed so that if one zone fails, operations shift to another without requiring a person to notice, let alone intervene. And verification, which for Egypt meant a seasonal audit against physical grain stores, now happens continuously and automatically. A single Azure storage account can handle over 2 million read and write transactions every second, and that scale is multiplied across millions of accounts. Every one of those transactions is checked, logged, and error-corrected as it happens, not once a year, but constantly. So the shift from Egypt to Microsoft isn't really a shift in principle. It's a shift in where the principle lives. Egypt built trust into people through training. Microsoft builds trust into infrastructure through architecture. The Scribes discipline became the system's design, and the seasonal audit became a permanent, automatic process running underneath everything, all the time. Strip away the papyrus and the server racks, and both systems are built from the same three ingredients. A standardized format that everyone agrees to use. Storage spread across multiple locations, so no single failure wipes out the record. And a verification process that checks what's written against what's actually true. Egypt built this with trained scribes, temple archives, and seasonal audits against grain stores. Microsoft builds it with data protocols, distributed data centers, and automatic, continuous checks. Different materials, same architecture. Line them up, and the similarities go beyond coincidence. Both systems rely on trained gatekeepers who have to prove themselves before they're allowed to touch an official record. Egyptian scribes went through years of formal education, while modern engineers work behind certified access controls and permission systems. Both systems spread their records across multiple physical locations on purpose, so a local disaster can't erase everything at once. Temples and granaries scattered along the Nile, data centers scattered across continents. And both systems check their own records against reality instead of just trusting what's written. Egyptian officials compared registers to actual harvests. Modern systems run constant checksums and reconciliation processes to catch errors or fraud. In both cases, authority stays centralized, one pharaoh's administration, one company, while storage stays deliberately decentralized because concentrating power is efficient, but concentrating the only copy of a record is dangerous. But pushing this comparison further starts to reveal real differences, and they're worth taking seriously instead of smoothing over. The pace of verification is not remotely similar. Egyptian audits happen once a year, tied to the harvest calendar. Azure verifies data integrity millions of times every second. That's not just a faster version of the same thing. It's a different category of system entirely, built for a world where information moves at the speed of electricity instead of the speed of a boat on the Nile. The threats are different too. Egypt's biggest dangers were physical and mostly accidental: flooding, fire, decay, an illiterate or dishonest local official. Microsoft's biggest dangers are often deliberate and invisible: cyber attacks and coordinated fraud that can be launched by someone on the other side of the planet, with no physical presence at all. Recovery looks different as well. If an Egyptian granary register was destroyed, rebuilding it might take a season or even a generation, cross-referencing whatever other records still existed. If a Microsoft data center fails today, the system is designed to shift operations to another region within seconds, often without a single person noticing it happened. And trust itself works differently in each system. In Egypt, trust was personal. You trusted a record because you trusted the scribe who wrote it, and his reputation was on the line. In the modern system, trust is impersonal. You don't know or trust any individual engineer at Microsoft. You trust the architecture itself, the redundancy, the encryption, the fact that the system is built to catch its own errors. That difference points to a pattern that connects both systems, even across 4,000 years. Every system built to protect trust is balancing the same three demands. A record has to be accessible enough to actually use, durable enough to survive time, and verifiable enough to be believed. Improving one of these tends to put pressure on the others. Papyrus was easier to access than stone, but far less durable. The cloud makes information available anywhere on Earth instantly, but only because of an enormous, mostly invisible verification system running constantly underneath it. And in both cases, the amount a civilization invests in redundancy and verification tracks almost exactly with how much depends on that trust holding. Egypt poured resources into scribal education and temple archives because its entire tax base and food supply depended on it. Microsoft pours billions into data centers and encryption for the same underlying reason. Trust is the actual product being sold, which points to something larger than either system on its own. Trust between strangers doesn't happen naturally once a group grows past a certain size. It has to be built deliberately, the same way a granary or a data center is built. Egypt built it out of trained people and physical audits. Microsoft builds it out of distributed infrastructure and constant automated checks. The materials change completely. The underlying task never did, making sure a record, once made, can still be believed long after the moment it was written. So here's the question worth sitting with. What's the granary register in your life right now? The record you're trusting completely, that has no backup, no audit, and no second copy? Tell me in the comments. I want to know what it is, and whether this video changed how safe you feel about it.